All right, moving along, we're going to keep talking about abrasion. This is already a word that you wrote down. So we said that rocks and sediments grind against each other. So this is an example of wind erosion. So wind picked up the rocks and basically flooded against these to cause these. So you can see an example of a dust storm. We saw one before. We will watch this video right now.
NASA scientists have performed the first multi-year study using satellite data to measure the 3D distribution of dust that travels from the Sahara Desert to the Amazon rainforest. The Sahara is the world's largest desert. At more than 3 million square miles, it's almost the size of the continental United States. Each year, Saharan dust is lifted from the ground and transported by winds on a 3,000-mile journey across the Atlantic Ocean. A portion of the dust collects in the Amazon basin, the largest rainforest on the planet. Although dust particles are small, no larger than around a tenth of the width of a human hair, they form massive plumes that can be seen from space. NASA's Calypso satellite was launched in 2006 to study the vertical structure of clouds and particles in Earth's atmosphere. Calypso observations from 2007 through 2013 show that on average, 182 million tons of dust leaves Africa each year. Of this amount, about 27 million tons is deposited in the Amazon basin.
Sahara dust contains.
So what he's saying right now is that the Saharan dust contains phosphorus, and then the phosphorus is really important for all of the plants that exist here in the Amazon rainforest. So this mass, migration of sediments and dust, chemical-rich dust, settles over here, and it's all part of just like a global ecosystem that's all connected. So this erosion that takes place is really important for that. So other examples of abrasion, we can see here that gravity could be a big part of it too, right? So when the gravity gives away, things can fall and destroy certain parts over here. So here's some examples of some landslides. Here's another really scary right here. I'm gonna move my mouse so that this will disappear, and then you can see what I'm talking about. This car is going to be driving along right here on the right, and then look how narrowly it misses, right? That boulder almost crushing that car right there. Really scary. I'm going to attach this 3rd Minute Earth video as well. You can watch it. It's really interesting. It just shows how basically there's a maximum height that mountains can get to before erosive forces basically take them down. So I'm going to attach that one and you can watch it as well. And then these ones I'm going to show right in here because these are both really interesting rock slides that were caught on tape. So here's the one on the bottom left. You can hopefully zoom in and see this. So rewind that a couple times if you want to see. And then there's this one. So here's another extreme example of abrasion. Now, I know this is mostly snow, so it's not exactly the same thing, more, I guess, erosion here. But since we are looking at examples of, gravity taking things down, moving things, I'm sure there's some rock mix in here, and you can see people running away very wisely. It's a scary situation here. This is at the base of Mount Everest, where, there you can see the huge avalanche coming in right there and how scary it is until you get inside of that tent. So this is just another example of abrasion and erosion taking course right here. Everyone, I believe everyone in this base wound up being okay. It was just the people that were really right underneath the mountain that may not have made it out okay. Another type of erosion that could take place is plants. Plants are very sturdy, very strong. They can literally, as you can see in the top right, just grow right over a rock, right through a rock, right? So if you ever were wondering why paper beats rock, in rocks, paper, scissors, there you go, right? So you can even see over here, this tree is almost like reclaiming this ancient temple right here, which is pretty interesting looking. So the next definition I'm going to ask you to write down is acid precipitation. It's another major form of weathering right here. So here, acid precipitation, maybe you've heard of acid rain before. So here's an example of acid rain down here. And this is what acid rain can do to a statue, another statue that was damaged by it. But really, it's any type of precipitation, rain, snow, and hail, which contains acids from pollution, which rapidly break down rock. Now, when I was younger and I heard acid rain, I imagined that it was literally like yellow acid that fell from the sky and it landed on you and it burned you and you screamed and it was horrible. That's not what acid precipitation is. Water has a certain level of acidity to it anyway, right? Just like vinegar has a level of acidity to it. So obviously vinegar more acidic than water, but different types of water are going to have more types of acid inside of it, right? So more amounts of carbon dioxide or other greenhouse gases that get released mix inside of the clouds over here, and then it comes down in that form, and then that can weather away certain things. So that's what we mean by acid precipitation. Just any kind of rain does this, but specifically the acids that get absorbed inside of it. Some of them could be natural. It doesn't always have to be from factories. Could be from like volcanic eruptions or any other source of carbon dioxide that's being emitted into the air can mix in and make the acid precipitation worse. So if you look here, this is the modern day Statue of Liberty. Now, this is not a real image, but this is what we think that the Statue of Liberty looked like when it was first given to us. So make sure that you write down as an example here, if you haven't written it down, an example is the Statue of Liberty here, because it went through chemical weathering, erosion, through acid precipitation. It's kind of the same reason like that copper that's inside of like pennies, sometimes they turn green over time when it gets exposed to water. Same thing basically happened to this over time, and now people don't even realize that it was originally that bronze color. I'm going to attach this video right here, so I definitely want you to watch this really interesting video of how the Gulf oil spill disintegrated this island in general. So that's another example of chemical weathering. And then we're going to talk about rates of weathering. So different types of rocks will weather away at different speeds. So the central area of this over here, right, was a lighter type of rock, easier to weather away than this one. So that's differential weathering. You don't need to write down differential weathering, just understand the concept of it, right? So this is a sturdier rock that isn't going to weather away as quickly. Eventually, these arches will crumble and it will fall down, right? But not as quickly as the stuff in the middle here. And this is why we pick for tombstones. We want to pick something sturdy, something that's going to be around a really, really long time so that in hundreds of years it's still standing. You don't want something that's going to weather away really quickly. So one of the worst things that you could have for this would be something like limestone. Generally, every single cave that you will ever see is made out of limestone. And an example would be down here. So this is a limestone cave, and the water is able to carve away. You're not going to see like a granite cave. It's just too resistant. So if you look here on this image, you can see sea arches, right? So it says wave action continues to erode a sea cave. So the wave reaches up this high, it weathers away this area. This particular area might either experience the most amount of waves, or as we were talking about, could be differential weathering, meaning that's a different type of rock that's getting eroded here. And then sea caves is really similar. So if this is limestone down here, this is what's most likely going to get eroded. Now, there's two amazing images. This is both from Planet Earth, and it's the episode for caves. If you can have access to that and watch it, it is one of the most incredible episodes of any documentary I've ever seen, specifically the caves one. It's so cool. So anyway, I'm going to ask you to watch this one. It's only about 2 minutes or so. And then this one, you just have to watch the first minute and 10 seconds of, and I'm going to post that one. So please take a look at both of those really interesting videos. If you take a look here, we're going to talk about different rates of weathering, meaning that we'd already talked about before how like certain types of rock will weather away faster, but also certain conditions will cause more weathering and erosion. So if you look here, you see how tall some of these areas are. If you ever seen the movie Avatar, they actually based those like worlds, I forget the name of the world in it, based on these like Chinese mountains that they have here. So these mountains were weathered away, right? Different parts here. And you're going to experience more weathering the higher up you go at a higher elevation, because the further you go up, it's going to be colder, right? As altitude increases, temperature decreases. So higher up in the atmosphere, you're just going to get more clouds, more condensation, more acid rain. And then because that water that's falling down on top of these tall, tall mountains, it'll freeze. You're going to get that ice wedgie that we talked about before. So that's one example of a faster rate of weathering. In really dry areas, this is one of the reasons why things like the Sphinx and all these pyramids that exist here in Egypt, because it's such a dry landscape, it doesn't weather away very fast. So there's a story of what's called Cleopatra's Needle, right? So there were 3 of these in Egypt, and they were there for thousands of years. And for thousands of years, very little erosion took place there. Then somebody there gave away them as 3 gifts. One went to Paris, one went to London, and one went to New York. And you can actually go and see it. It's right behind the Museum of Natural History. It's called Cleopatra's Needle. This is what it looks like right over here. And I know it might be a little bit subtle to see, but you notice all this erosion that took place over here and how much little the top, how different it looks up there. So basically, within a little over 100 years of this coming over here, it experienced more erosion in that hundreds of years than it did for thousands of years in the drier climate that would be out here in Egypt versus the more temperate climate that we experience here closer, on the East Coast. So a lot more water in the air causes this to take place as well. If you look over here, right, this line right over here represents the equator. And every single one of these mountains is one of the tallest mountains that exists over here. One of the reasons that you see this increase in really tall mountains around this area, like a lot of them seem to be closer into this area, is simply because there is less weathering and erosion that takes place there. You are going to have some in different areas like up here, but if you notice those, it's just a cluster of them closer to the equator because it's going to be generally a little bit warmer and it won't be as cold, where you're going to have a lot of that frost and ice wedging that's going on there. And the last thing that I want you to do is to watch this awesome video. And as you do it, I want to see if you can keep track of every single time that there is an example of weathering and erosion, or something that we learned about going through. So I'm talking about, think of ice wedging, think of rain, acid precipitation, think of rocks getting eroded, carried away from one place to another. And I thought it was just a really awesome thing that demonstrated lots of different types of weather and erosion. All right, and that's it for your weather and erosion. Thank you, everyone.